Hello, I'm Eren, a first-year master's student at the University of Alberta. Today I'll be presenting structural analysis and preliminary results of numerical tectonic modeling of the Scotian Basin. And this study involves the structural analysis part of the project, which is called Application of Source Sink Sediment Model to Petroleum System Analysis of the Scotian Basin from Field Studies and Numerical Modeling. The Nova Scotia continental margin is characterized by longitudinal variation in crustal structure and amount of extension from the volcanic U.S. Atlantic margin in the southwest to a non-volcanic Newfoundland margin in the northeast. The central and northeastern segment of the passive margin experience higher degree of crustal thinning compared to the southwestern segment of the margin. The motivation of this research is to describe several sets of faults to delineate tectonic structure of the basin and to carry out structural reconstructions to quantify sediment loading and tectonic extension during the Atlantic opening and to assess the impact of salt kinematics and evaluate both onshore uplift and erosion, also offshore substance across the passive margin. 78 wells, including their well tops, master logs, checkshot or VSP, and also 2D seismic surveys acquired and reprocessed through time were used as dataset. Importing well data and seismic lines was the first step of the study. Missed-style analysis between different seismic surveys was followed by constructing TDRs and seismic well tie studies. Velocity data calibrated with time and depth surfaces were used to build velocity model and to convert metaprobe lines into the depth domain. Then 12 marker horizons and faults were interpreted in both time and depth domains. Magnetic and gravity surveys were also integrated with seismic interpretations to highlight tectonic elements of the basin. And finally, 2D sequential restoration of the selected depth line was carried out to quantify amounts of extension and sediment loading. The first group of results involves the structural interpretation. What I would like to highlight here is that the northwest-southeast trending seismic line denotes 5 different fault sets. The first group of fault is the northeast-southwest striking scenery faults bounding northeast-southwest oriented porcelain grabens. They correspond to the onset of the continental breakup during Triassic to early Jurassic. The southeast dipping glycerine faults flatten into the deep detachment located at around 15 km TVDSS to the southeast of the continental ocean boundary are the second set of faults. The southeast dipping glycerine faults and rollover anticlines in the Jurassic strata developed above detachment along the downslope propagated alloctonous salt is in the distal part of the basin. Cretaceous southeast dipping normal faults are associated with the salt remobilization and gravitational sedimentary loading under the slope settings. Banding-related crustal southeast dipping normal faults are also developed as a result of movement of salt diapirs. The second group of results is preliminary results of the 2D backstripping modeling. The workflow of 2D sequential restoration started with the importing seismic line and interpretations in depth domain. After creating proper polygons for each stratigraphic units, compaction curves were built using well data. So fault restoration, unfolding using appropriate regional lines, thermal subsidence, and decompaction algorithms were applied for each unit respectively. The change in length of cross-section through time provided stretching factor. The pinpoint on the shelf also were used as a proxy for paleotopography of the basement. In conclusion, fault geometry varies along the margin and is likely controlled by presence and depth of ductile basal detachment and mechanical stratigraphy of the Mesozoic sedimentary succession. The southwestern segment of the passive margin is less faulted than the northeastern segment of the non-volcanic margin. And the ECMA marks transition from planar to lithologic growth scenery faults in Triassic to lower Jurassic beds. 2D sequential restoration model provides an insight into the paleotopography of Mesozoic sedimentary succession and basement through time. The stretching factor for the upper crust in Nova Scotia passive margin is calculated as 1.47 and is compatible with previous studies. And finally, we would like to thank Mark Cooper and Marianne Boren for their support and help in structural interpretation. Russell Dimitri, Duncan Kepier, Natasha Morrison, and Oera for financial and technical support of the project. Schlamerger for providing an academic license of Petrel to University of Alberta. And petroleum experts for academic license of MOVE and their very helpful technical support. Thank you.